All right, so yesterday we ended here. What? Make everything go. All right, let's look at number 8. So remember, when we're going to prove these, you want to manipulate the side that looks more complicated. So which side would you say that would be? The right side. So that means the left side is our goal. So I'm going to circle this because this is my goal. And I'm going to rewrite that. Sine of u plus cosine u. And yes, you have to rewrite it every time. And you cannot do something and say, oh, well, right now I'm just working with the numerator, or I'm just working with the denominator. That's fine, but you still have to rewrite the rest of it. Because at every step, you have to show that the two sides are still equal. So what we have here is we've got secant and cosecant and tangent and cotangent, but nothing is squared. So I cannot use the Pythagorean identities to change the secant to the cosecant. If I did have some of that squared, then I might want to try and use one of those. But since I don't, really my only options here are to start using the reciprocals. And we're going to have lots of fractions and fractions, which does not make things more difficult. You just got to keep up with what you're writing, okay? So secant, I can rewrite this as 1 over what? Cosine. So this is 1 over cosine of u plus cosecant is what? 1 over sine of u. Then in the denominator, tangent as a quotient is what? Sine over cosine plus cotangent is cosine over sine. Okay? Everybody with me so far? So I've got fractions and fractions, right? No reciprocals. I'm not flipping and multiplying at this point. I'm not canceling anything out. None of that stuff is legal right here. I mean, I could multiply by the reciprocal, but that would be really, really yucky to do right now. I would not suggest that. So instead, I'm going to rewrite the left side again. So sine u plus cosine u equals. Now, most of the time when you have two fractions, you want to try and put them together. So I'm going to take the numerator and I need to get a common denominator. So I'm going to make this big fraction bar. That's actually the middle of this. So in the numerator, those two fractions, what would my common denominator be? Cosine u, sine u, right? So my denominator in the numerator is cosine u, sine u, which means when I do that, this first fraction has to be multiplied by sine over sine. So that 1 gets multiplied by sine. So this just becomes sine u. This second fraction had to be multiplied by cosine over cosine, right? So that'll be plus cosine u. Everybody with me so far? And I'm going to make this a different color. So this is like this is this fraction bar right here. So you don't get lost in that. Now, that sine u plus cosine u in the numerator right here, can I make this into, is that 1? No, because it's not squared, right? Sine squared plus cosine squared is 1, but that's not what this is. So now I look at the denominator, and I need to get a common denominator there. What's my common denominator in the denominator? Cosine u, sine u. Right? So then the numerator of that, this first fraction had to be multiplied by sine over sine, so this becomes sine squared. The second one had to be multiplied by cosine over cosine, so this is cosine squared. And that's what I get. Everybody with me so far? So now the denominator just has one term. It has a lot of stuff going on, but it's just one big term down there, right? So now I can multiply by the reciprocal. So I'm going to rewrite the left-hand side. Sine u plus cosine u equals, and then I write the numerator, which is sine u plus cosine u over cosine u times sine u times, and I'm going to multiply by this reciprocal. But can I, at the same time, substitute something? Yeah, 1. Sine squared plus cosine squared, this right here equals 1. So like it doesn't just cancel out and go away, it equals 1. So right now I have 1 over this, so when I multiply by the reciprocal, I have cosine u, sine u over 1. Everybody okay with all that so far? Okay, so now, well, let's pause for just a second, because I wanted to ask you something kind of right here. Right here, before we even do that, can I cancel this cosine with this cosine? No, that is a big fat no. If you have addition and subtraction, be very careful, because that's where you're getting hurt with this stuff and making stuff up. But these two fractions that I'm multiplying together, can I cancel anything? Yes, this whole thing cancels with that whole thing. So now I get sine u plus cosine u equals sine u plus cosine u, and we're done. They're like puzzles. They're fun. You feel a sense of accomplishment when it works out. Yeah, it's really not that bad. It requires a lot of writing, and you have to rewrite it. You can't get lazy. You cannot skip steps. You cannot leave out equal signs. It's just going to make your life difficult. Okay? Everybody good? All right, so let's look at number 9. Now, when I ask you, which side looks more complicated, that is a matter of opinion. But most of the time, you want to try and get rid of a fraction if you have a fraction. Like it's better usually to try and work with this to get here than the other way. Because we'd have to square that and it becomes a trinomial and it's a whole thing. So we're going to work with the right-hand side. Here's the problem, is that I can't substitute any of the Pythagorean stuff in the numerator because it's not squared. So I can't do that. I could do reciprocals. Cosine is 1 over secant, but I don't know that it's not going to get me anywhere, right? Even if I got common denominators, and sometimes you don't know that starting off. Like you try, like, okay, I'm going to make reciprocals, I'll get common denominators, and you're just kind of getting nowhere. So every now and then when that happens, you have to just back up, start over, and try to go down another road. And this one, you have to think outside the box a little bit. Okay, and I know that's going to make you uncomfortable because the kind of things you start thinking is like, how am I going to know to do that? Well, kind of when you've exhausted all other options, maybe you try this, right? Like I've got to get something squared in there somewhere, right? So I can, what can I multiply anything in the world by and not change its value? 1. So when you're trying to get common denominators and stuff, aren't you multiplying by like 2 over 2 or 3 over 3? Like anything that's like that's a value of 1. As long as 0 isn't involved, a monkey over a monkey is 1. That's just the way it is. So I can multiply this fraction on the right-hand side by any value of 1 and not change the value, but maybe get it to something that I want to use. So I don't want to use anything random. I want to use something that's actually there. Let's rewrite the left-hand side first. So cosecant A plus cotangent A squared. So probably the best thing to try most of the time for these is to use either the numerator or the denominator and use that. Either 1 plus cosine over 1 plus cosine or 1 minus cosine over 1 minus cosine. It does, and try and figure out which one would be the best. If I did that, if I picked either one of those, or just think if I multiply the numerator and denominator together right now, what's that a special case? What's it called? Like it's a special, if I multiplied them together, which is not a legal thing to do. I'm just saying if I have to choose one of the two things, it's going to be multiplied. So it's a difference of squares, right? Okay, yeah. So like x plus 2, x minus 2, that's a difference of squares, right? Y'all remember doing that? Yes? So if I had like even x plus y times x minus y, that would give me x squared minus y squared. Yes? Okay. So if I did that, then I'd get a 1 minus cosine squared. Does that make sense to you? And can I substitute something for 1 minus cosine squared? Sine squared, right? Isn't 1 minus cosine squared sine squared? Okay, so now I got to think, where would I rather have this single term? In the numerator or denominator? Denominator for sure. Like we don't like it when there's 2 terms in the denominator. So because I'm thinking I would rather have that single term in my denominator since I get a choice, I'm going to rewrite this first. I get 1 plus cosine A over 1 minus cosine A, right? So that equals, oh, that doesn't equal, I'm sorry. That's not what I meant to do. And so I'm going to multiply that times a fraction. Well, I want the denominator to end up being a difference of squares, so that means I'm going to use 1 plus cosine A, which means the numerator has to be 1 plus cosine A, because now that fraction has a value of 1, and when I multiply them, then it's, I'm going to get the difference of squares in the denominator. And it doesn't change the value, just change the way it looks. We all good so far? Okay, so let's go to rewrite the left side again. Cosecant A plus cotangent A squared. So in the numerator, I'm not actually even going to multiply that stuff together. How could I write this in a very simple way? Instead of, I could actually multiply the 2 binomials, but what else could I do? They don't cancel. Okay, so if I put parentheses, I am going to need parentheses. I put a square on it. Isn't it just 1 plus cosine A squared? and not actually squaring it? Okay, but let's back up here because I heard cancel, and that's okay because this happens all the time. Because this is what somebody got stuck on the quiz I gave the other day. And like right here, because you can cancel those out, then you end up with this. And then he'd get a common denominator again, then he'd cancel again. Like he was in this vicious circle. Like and he was so confused. I was like, dude, you just kept doing the same thing over and over again. So be very careful not to cancel. But the numerator, instead of making it complicated, I can just make it 1 plus cosine A, and then that's quantity squared, right? In the denominator, the whole reason I chose that one was because that's going to give me a difference of squares. So I'm going to go ahead and multiply that out and get my 1 minus cosine squared A. Everybody good so far? Any questions?
Why is it cosine 1 minus cosine squared A?
Because it's the difference of squares.
Oh yeah, and it's over. Okay.
Yeah. So with the difference of squares, it's 1 minus, or it's the first thing squared minus the second thing squared. Okay. All right. So then here, I'm going to rewrite the left-hand side again. So cosecant A plus cotangent A squared equals. So can I cancel a cosine here and here? No. All right. But I can't remember the whole reason we thought that might be a good idea is 1 minus cosine squared is what? Sine squared. So the numerator is 1 plus cosine A quantity squared all over sine squared A. Then I'm going to rewrite the left-hand side. Cosecant A plus cotangent A squared equals. All right, so now let me ask you this. This is kind of a little side note so I can get you to where we need to be here. If I tell you to take 3 halves and square it, how do you square a fraction? Square the top and you square the bottom. So would you agree that this is the same thing as 3 squared over 2 squared? Yeah. Yes? So if I have something that looks like this, I can actually put it all in one set of parentheses, right? Notice how here I have something squared over something squared. So what I'm going to make this into is big old parentheses squared. This is the squared part of the numerator, 1 plus cosine A. And then the denominator would just be sine A. Because it's still squared, it's just kind of squared in a different format. Everybody okay with that step there? Okay. All right. Now rewrite the left-hand side again. Cosecant A plus cotangent A squared equals. Now now that I have this fraction, I finally got some parentheses with the square on it, so that's good, like I'm getting somewhere. So I got to deal with what's going on the inside. What's something I can do with what I have on the inside? Multiply what? I can separate it. I mean, I could, I guess, multiply by the reciprocal of that, but I don't know if that would help me any. But I can separate, I can split the fraction, right? So I still have these big parentheses, and this will give me 1 over sine A plus cosine A over sine A quantity squared. Okay, so that's totally legal. You only split it when you have more than one term in the numerator, not when it's in the denominator. Be careful with that. Rewrite the left-hand side. So what is 1 over sine A? Cosecant. And cosine over sine is cotangent. And we are done. Now, let me tell you that this one, it's a little out there, I know. I know you have to kind of just know what to do at the beginning, and that comes with some experience. And Ms. Archer and I discussed whether or not we were going to do this one and leave it on the homework, but we decided we were going to go ahead and show you what to do and how to do it. We're not going to put one like this on the test, so I don't want you freaking out over it. I just want you to kind of follow along with the thought processes, and then I think, you know, when you see the more difficult stuff, it makes the other stuff seem a little easier too. Okay, just a good, maybe as a bonus, yeah. Okay, yeah, I don't think so. All right, we good? Okay, sometimes that still wouldn't help some of you. All right, let's look at number 10. Number 10 is not nearly as crazy, okay? I promise you. So I would say that the left-hand side definitely looks more complicated. Would you agree with that? Nothing squared over there that I could do a Pythagorean anything, but I have 2 fractions, so I want to be able to put them together, which means I need a common denominator. What would my common denominator be? Exactly. So you're just going to multiply these two things together, basically. So it's 1 minus cosine y times sine y. Did I write that down correctly? No, what do I need? Parentheses. Okay. And the good news is I don't even plan to distribute that right now. Maybe we'll need to, maybe we won't. So I'm not going to do it until I decide if I need to. Because sometimes we distribute too early and then realize, oh, we shouldn't have done that. We have to factor back out. All right, and this is going to equal 2 cosecant 1. All right, so when I do this, this first fraction then has to be multiplied by sine over sine, which means this becomes sine squared. Right? Oh, sine squared y. Yes? This fraction has to be multiplied by 1 minus cosine y over 1 minus cosine y. So this becomes plus 1 minus cosine y squared. Everybody with me so far? Ask me questions if I lost you somewhere. I put them all together instead of making them separate fractions. Do I need to write it out as separate fractions? Y'all need to speak to me if I lost you. We're good? Okay. Okay, so now the denominator I'm still not going to distribute, but in the numerator, if I don't actually square that stuff out, I'm not going to be able to get anywhere. So I'm going to rewrite this sine squared y. Now this binomial, when I square it, does that become 1 plus cosine squared? No, it absolutely does not. It becomes a trinomial. You have to FOIL it, right? And so this becomes plus 1, and then it would be minus 2 cosine y plus cosine squared y. Because you're actually multiplying 1 minus cosine y times 1 minus cosine y. You got to FOIL it. Okay, but it's a special case, so you should be able to just write it out too. It's why this factoring and multiplying and being able to do this stuff quickly is so important, because that's a very small part of what we're doing here. And then I'm going to put this all over 1 minus cosine y times sine y equals 2 cosecant y. Everybody with me so far? All right. Where did I lose you? Okay. So like, look at the numerator. Is there anything that you see in the numerator that might have something we could substitute for? In the numerator, yeah. Well, first of all, like, can I cancel these things out here? Like, there's nothing I can cancel at this point. But sine squared plus 1, maybe that could give me something. What else do I have? This sign with this, no, because there's addition and subtraction up here. Okay, but look, I got this and this. When you add those together, what do you get? 1. Isn't sine squared plus cosine squared 1? You agree with that? And so even though they're added, they're not right next to each other. You can add in any order, right? So we have that. So this and this, sine squared plus cosine squared gives me 1, plus there's still this 1 right here. 1 minus 2 cosine y all over, and then I rewrite 1 minus cosine y times sine y equals 2 cosecant y. Everybody with me so far? What's 1 plus 1? 2. So I'm just going to make this part in here into 2. So I have 2 minus 2 cosine y. I still have 2 terms in the numerator. What can I do in the numerator? What can I do in the numerator? I got 2 minus 2 cosine y. I can factor out the 2. I got a GCF, right? 2 terms, they both have a 2 in it. So I'm going to factor out the 2. That leaves me with 1 minus cosine y over 1 minus cosine y times sine y equals 2 cosecant y. So, can I cancel anything now? Yes, I have addition and subtraction, but it's within the terms. They're really just like one big term. So I can cancel this with that. That leaves me with 2 over sine y equals 2 cosecant y. Now, when you take the reciprocal, because you have 1 over sine, it doesn't flip the whole thing where like 2 becomes the denominator. 2 is still there. Another way to write that, although you don't have to, that's the same thing as 2 times 1 over sine y. Does that make sense? Like, it's just not written that way. So what is 1 over sine y? cosecant. So 2 cosecant y equals 2 cosecant y, and you're done. Okay. If you actually, work through these things, it'll become easier and easier as you go through the assignment. Try not to overthink it. Make sure you're looking at this and trying to think about what the simplest thing you could do at that time is, okay? Any questions at all? Yes, you will always get this. All right, I'm going to go ahead and give you your assignment, and then there's one that you need to eliminate. On the assignment, you're eliminating number 3. I will remind you of that when I give it to you.